And in the final part of lesson 2.3, where we're looking at zeros of polynomial functions, we're going to use, we could use either synthetic division or long division and the remainder theorem all combined together to show that x equals 1/2 is a zero of this polynomial f of x. If it is a zero, then the polynomial could have, the factor associated with this would be x minus 1/2. So we could do this with synthetic division, just putting in 1/2 here. We have any missing powers? No, we've got x cubed, x squared, x power 1, and a constant. Nothing's missing. So just put in your coefficients. 2 minus 15, 27, and minus 10. Bring down the 2. 2 times 1/2 is 1. Add those together. You've got minus 14. Ooh. Minus 14. Minus 14 times 1/2 is minus 7. That gives me 20. 20 times 1/2 is 10. And so I end up with a 0 here. The remainder is 0. And because the remainder is 0, this means that x equals 1/2 is a 0. It would also mean that it would be a solution to the equation. If this word hadn't said it's a 0, if it had said it's a solution, it would be a solution to the equation 2x cubed minus 15x squared plus 27x minus 10 equals 0. It would be a solution to that. Because how you would normally solve that is you would factor it. And that to factor, could you have factored it? We might have actually been able to do that one. It would have been horrible by grouping, wouldn't it? Ooh, no, I'm not seeing anything nice there. That would have been very difficult. Could we have actually factored it by grouping? We could pull that x squared. We would have had 2x minus 15. And then plus, nah. You couldn't have done it by grouping. It would have been really difficult to factor it. So this was a much better way of doing it. But we haven't finished yet. Then find all the solutions to the equation this equals 0. Okay? It's a badly written question. This word should then find all the zeros. Find all the zeros. So we found one of them and divided it out. This quotient, if something is a 0 of this, once I've divided out one of these factors, what's left over, if anything that's a 0 of this, will also be a 0 of that. So all I have to do now is factor what's left over. This is standing in for 2x squared minus 14x plus 20. If I factor that, oh look, we've got a GCF. 2 times x squared minus, I forgot the x there, minus 7x plus 10. If I factor this, I can find the remaining zeros. So this would be 2 times x and x, factors of 10 with a sum of 7. Oh, that's 2 and 5. This is nice and easy. And to get minus 7x, they must both be negative, and that does give me plus 10. Double check it, multiply it out. I've got x squared, my outer is minus 5x, my inner is minus 2x, and my last term is plus 10. So yes, this is working. Okay, let's erase that. So my other zeros, are the zeros of this quotient I got. I've got x equals 2 and x equals 5. You're struggling to believe me. I'm struggling to think this is right. Let's see. If x equals 2 is a 0. I could have done this right from the beginning. I could have put 2 into there. Oh no, I can fit it in this little space. This is going to be ugly fitting it in so small. 2 minus 15, 27 minus 10. 2, 4, minus 11, minus 22, 5, 10. See, it does work. But you don't have to do that last bit. I only did it to prove to you that I could find the zeros of what was left over after I'd divided out a nasty thing they gave me. So that's another use you can do. You can solve equations set equal to 0 and find other solutions to the equation where a polynomial equals 0. Okay, all of these would help you if you were trying to graph these and you had to find the zeros to put them on the number line on your graph, on your x-axis. Okay, I think we're done.